All apprentices and delivery staff must wear PPE at all times in an official workshop. Note that these practical examples are filmed in a teaching environment.
So finally, with our continuity testing for radial circuits, the other problem we have is testing the direct online starter circuit right up to the motor terminals. As you can see, we're going to need to go through the contactor, which during a dead test is going to be in the open position, but we do have to test right up to the motor terminals. So there are several ways you can do this. On site, you may have a friendly friend who can hold that contactor in the closed position for you, pushing that in. That's one way of achieving a test right to the end. But if you need to demonstrate that you can do this test when you haven't got any support and you're on your own, then this is the way the test needs to be carried out. In the first instance, we go back to our three-phase circuit, and what I've done here is I've connected line 1 to the CPC, giving me an R1 and R2 on line 1. It's important you do these one at a time. I mean, thinking about it in theory, it would work if you connected all three in there at once, just giving you one job to do. But remember, we're doing R1 and R2 as well because it gives us a polarity check as well as testing our CPCs. So we're going to do them one at a time, and I've got my L1 connected first this end. The next thing I need to do is link out the motor terminals here. So the way we got this set up, this is quite handy because I can just use a test lead to link between the connectors to create this short. So with this lead here, we plug one end into L1 and the other one into the earth. So this has now created our R1 and R2 link ready for the test. Of course, I've also added the value of resistance of this lead into this part of the circuit. So I need to make a note of that. I've measured that earlier and it actually came to 0.1 ohm. So I'll make a note of that because I am going to need to deduct that from the final figure. Having already zeroed out my leads, all I need to do now is complete my test. So the first test is from line 1 on the incoming side, top of the main switch, and between the CPC, and the value there is 0.09 ohms. So I'll just make a note of that. So back to the dB is 0.09 ohms. And now I need to test the circuit up to the motor. So that was from the outgoing side on actually terminal T1 to my CPC, and a reading there of 0.11 ohms. So that is then 0.11 ohms. So I got my R1 and R2 values now from both sides, from the motor, from the contactor, and to the dB from the contactor. Now I need to find out the overall resistance of the circuit from the dB up to the motor, and I'll do that by adding these two together. So from the motor to the dB added together rather conveniently comes to 0.2 ohms. But don't forget, I must deduct from that the value of resistance of the lead we use to link out at the motor side. So then that gives us an actual overall resistance of 0.1 ohm. So now what we need to do is to repeat that for phase L2 and for phase L3. And now we have our three values of R1 and R2 for each line of the three-phase supply to the motor. So let's get this recorded on the paperwork. So for this one, being a three-phase supply, we're going to take 3 lines of the test certification. So 3 lines all the way across, and we're going to record then for L1 it was 0.1, for L2 was 0.1, and for L3 it is 0.11 ohms. And again, It's not a ring main, so we don't need those. And we've opted for the R1, R2 version on there. So that's where you record your 3 values for the continuity of CPCs, R1 and R2, for your motor circuit.